Okay, so this is the 2024 Canadian Chemistry Contest, and we'll start with question one, which is question one's over here. Which of the following symbol is used to label helium tanks? So, as we know, helium is a inert compressed gas, which means that the symbol for this would be D. Over here, this symbol means that it's a gas that's under pressure, or like a gas cylinder, and it is used on helium tanks. The other symbols are flammable, toxic, irritant, and oxidizer, so which is none of what describes helium. Moving on to question two, we can see that they tell you that we are given an equation over here. I won't talk about the problem much, you can read it right now. But then we are given an equation, and it tells you that if we recovered zinc chloride products, if like the recovered zinc chloride product were insufficiently dried before weighing, which of the following statements is true? This is basically asking that if ZnCl2, which is zinc chloride, was not sufficiently dried, which means that you have to add on the weight of the water, or the H2O, then the extra water inflates the product mass, which also inflates the calculated mass of the chlorine. Because we're using the moles of zinc, and we're just like calculating the mass of this and then to subtract the zinc, which means that we'll get too much mass of chlorine, which would make the number of moles of chlorine also too high, because we're having more mass and therefore more moles of chlorine. And for question number 3, we can see that it basically asks us that if not all the zinc reacts, then the actual mass, what would happen to the reaction? So like, if the zinc doesn't fully react, the actual mass of zinc that enters the reaction is less than what the initial mass weighed. So the moles of the chlorine calculated, moles of chlorine calculated, would equal the mass of the zinc chloride 2, which is the initial mass of the zinc. But because this thing has gotten smaller because not all the zinc reacted, but you still subtract the full initial zinc mass, then the apparent mass and moles of chlorine would also drop. Not unchanged. Sorry, I circled the wrong one. It would be too low, so it would drop. And moving on to question 4. Here it tells you that there is 4.49 grams of CO2. And for these questions, we can calculate the molar mass of CO2, which is 44.01 grams per mole. And for any of these calculations, you have to convert these to moles. So you divide by this value to get the moles, which is equal to 0.102 moles of CO2. And for the other one, we tell you that we have 2.45 grams of hydrogen of water. So from this, we can calculate that there's 0.2722 moles of water. So over here, we can see that the ratio of C to H is equal to 3 to 8. So which means that the formula for this hydrocarbon would be C3H8. And this has a molar mass of 44.1 grams per mole. So then the moles of this, we are telling that there's 1.5 grams. So then there's a total of 0.034 moles. And since there's 0.03 moles of the hydrocarbon, then we can calculate the molar heat of combustion for this hydrocarbon as combustion equals to negative 75.5 kJ divided by kilojoules divided by 0.034 moles, which is equal to negative 2.22 times 10 to the third, or A. Okay, question number 5. We're told that at STP, 20 milliliters of gas A react with 20 milliliters of gas B to only produce 10 milliliters of gas AXBY. We're told that there is 10 milliliters of excess gas A, and they want the empirical formula. So then this ratio right now is 20 gas A, 20 gas B, turns out to be the 10 of the final gas. So, which equals 2 to 1. So then this would immediately signal the answer choice of D. Because you can see that they told you that there's excess 10 milliliters of excess gas A. So which means that over here, if we find out the ratio, it's a 2 to 1. So you can see that B doesn't supply enough. So basically there's 20 for B. 20 mils times 2B over A, which is, you can cross out these things so you can see that there's only 10 ml left. Okay, so then that would be D. After you see that, the ratio like that, it's definitely like that. Okay, question number 6. Chlorine bleach can be synthesized by bubbling chlorine gas into a solution of sodium hydroxide according to the equation. What mass of sodium hypochlorite is produced when this amount of chlorine at this pressure and temperature is reacted with 250? Okay, here we can see that there is a total of, using the gas law, PV equals nRT. We can arrange this formula to get that N equals PV divided by RT. Plugging in these numbers, we can find that the number of moles of chlorine is equal to 0.14 mole. And that the number of moles of sodium hydroxide is equal to 0.1875 mole. So then every 2 moles of sodium hydroxide per 1 mole of chlorine, so which means that this is a limiting. This is a limiting reagent. So since this is a limiting reagent, the number of hypochlorite, sodium hypochlorite, is equal to half of the amount of the limiting reagent. And the mass of the sodium hypochlorite is 74.44 grams per mole. So we just times these two together to get 6.98 grams, or C. Okay, question number 7. In a reaction, dichromate ion is reduced to chromium ion in an acidic solution. What is the sum of all the coefficients which this half reaction is balanced? Okay, so over here, we can see that they want us to balance that the chromium, and over here they want us to change it into this. Okay, so how we balance this right now is, this is 2 minus, this is 3 plus. So we can see that we're missing 7 H's. We can see that we're missing 7 O's, oxygens. So we have to add 7 H2O to compensate and balance it out. So after we got here, since this is 14H, we also have to add 14H plus over here. So this is all the elements that's inside. And to balance this is you can see that this is already a balanced thing, except that you need a 2 here. So we just add this 2 here, and this becomes a balanced equation. But then the electron isn't complete yet, because this is 14 plus, this is 2 minus, this becomes 6 plus, and this is neutral. So over here, there's a charge of 12 plus, and there's a charge of 6 plus, which means that we need to add 6 electrons to the left side. So we also have to insert 6e minus. So over here, there's 14 plus 1 plus 6 plus 6. Oh, not 6. Sorry, plus 2. Plus 2 plus 7, which equals a total of 30. Or E. Okay, next question. They told us that if 20 milliliters of 1.0 mole sulfuric acid is added dropwise to 40 milliliters of 0.5 mole per liter barium hydroxide, a precipitate of barium sulfate forms. Which graph represents a plot of conductivity against the volume? So the conductivity is the number of ions that's in the solution. And we see that before, there's definitely going to be a lot, because the original equations, barium hydroxide plus this equals BaSO4 plus 2H2O. Okay, so since this is a case, this is not conductive, and water is definitely not conductive. But then before, these two were conductive. So that means it'll have a constant drop of conductivity as it begins to break down into a precipitate. So we can see that the only thing that drops down is B and D. But then there's no reason for it to bounce up as a V-shaped, which means that only B is valid as it is a constant drop. Moving on to question 9. This question is 9 and 10 actually, as it is the same question. So over here we can see that this one only wants us to find the chemical formula of the substance, which they've given the graph over here. So this graph. So basically, first we obviously count the carbon, which is 1, 2, 3, 4, 5, 6, 7, and 8. So since there's 8 carbons, we can cancel out A, C, and E. And then after this, we need to count the number of hydrogens. As we can see that the O's, we can see that N and O matches. So there's no point in counting these. Only the hydrogens differ. So from here, we can see that this already has 4 bonds. This has 4. This has 3, so that there's an H linking here. This has 3, so there's a linking here. Another H, 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 and there's 2 here. So we count this up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this brings us to 12 hydrogens. And moving on to question 10, this asks us which one is false. So, over here, we can see that the CO over here, this is this carbonate is an amide, not a ketone. So, and we can also see that all the other statements are true. This has 14 pairs of electrons. I won't count it, but you can count it and you'll see that there's 14. This also has 3 hydrogen functional groups. 1, 2, 3. This one's also correct. It is capable of hydrogen bonding. There's alcohol. There's nitrogen. There's nitrogen. So this looks very possible to be hydrogen bonding. And it does not contain any alkene. And we can see that there's not a single carbon connected by double bonds. There's no isolated bond, so which means that this is also correct. So the only incorrect one is A.